All right. Hello, everybody, and thanks for joining today's OBO Academy session. We're going to be doing something slightly different today in that we're going to be doing a hands-on workshop about the OntoGPT tool. So I'll go over the basics of what OntoGPT is, what it's supposed to do, how it can help in an ontology-focused workflow, depending on how you work with ontologies. Uh, and then I'll jump and provide some examples. And if you'd like to follow along on the tutorial, you can do so, or you can just watch. I'm going to be pasting a link in the chat to the corresponding page in the OBO Academy docs. And that's what I'll be working off of today. So I'll also be sharing that here. So the general idea about OntoGPT is right around the time when these large language models, and I apologize, I have a cat that insists on sitting on my mouse and yelling at me when I attempt to remove her from it. Uh, the idea of OntoGPT arose back when the LLMs first began to demonstrate their prowess at doing a lot of the things that traditionally we've had to write kind of custom natural language processing approaches for. Uh, this and at times, especially in kind of a biomedical and biological space, sometimes this was something as simple as, okay, I have a document, I want to recognize everything in it that's the name of a gene or the name of an animal or the name of a drug. So you'd have tasks like this kind of concept recognition or named entity recognition. And part of the battle was, okay, I want to find these terms, but then I want to be able to link them to something in a database of some kind. Like if I have, a protein with this name, I want to be able to recognize, okay, well, this protein might actually go by a variety of different names, but I want them all to link back to one single entry in a given resource. And in practice, that's the kind of thing that we can design computational approaches, and in fact have for several decades now, that will do pretty well at this. Sometimes that's based on more rule-based approaches, like, okay, well, I'm going to look for every instance in the text that says, okay, the protein, and then assume that somewhere in that sentence there's going to be a protein name. Or I'm going to use more of a dictionary-based approach where I'm just going to give my software a whole list of every protein name that I know of, and if it finds one of them in the text, well, that's good. It can look it up in my dictionary and then cross-reference that to some kind of identifier. And as I mentioned, those can work pretty well. Where things begin to get a little bit more complicated are at least two situations. One of which is that the space of names that you may be looking at is growing every day. Uh, People may not discover or name new proteins every day, but they may discover other things like those drug names that I mentioned. There are new drugs, entering our human knowledge on a regular basis, and we don't want to have to constantly update our methods to recognize these new names, although that is an option. The other complex thing is that, well, these names aren't always mentioned in a very explicit context. Yes, with things like drug names or protein names or genes, yeah, we may explicitly mention them. But sometimes with things like diseases, well, they don't always follow a predicted way of describing a disease. If I say heart attack, well, that could be expressed as myocardial infarction. That could be expressed as MI. That could actually be in a variety of different other languages or contexts, or maybe somebody even misspells it, and we still want to be able to recognize from context. Oh, well, they were talking about a myocardial infarction. So as we begin to expand the space of other potential variations of those given phrases, and even other potential contexts, maybe we want to take things a step further and say, okay, well, I I know this patient experienced a heart attack. I have a document that says that they did. It just doesn't explicitly say that they experienced a heart attack or myocardial infarction. There's just other words in the text that might be able to suggest that. And that's when we begin verging into another kind of natural language processing, or more broadly, information extraction task entirely, which is more along the lines of concept recognition or relationship extraction. Where we either want to be able to extract, kind of a higher level concept from the available information that we have, or in kind of a more structured way, say, okay, well, we know there's a relationship between two or more things here. Uh, in practice, if we go back to our example of proteins, that may be something more like, okay, well, I know these two proteins interact. There's something in this text that's going to suggest that they interact because maybe they participate in the same process, or maybe this one disease is known to be associated with a particular set of symptoms, and I want to be able to express that as relationships between the disease and the symptoms. Then maybe even combine them with other relationships from other sources, like, okay, well, we use this therapy to treat this disease, or this therapy to treat this specific symptom that may be associated with this disease, or maybe in some context not even associated with that disease, just in this one case. So things begin to get a bit more complicated as it's all based in human language, and well, human language has a lot of meaning embedded in it. So all this is to say that OntoGPT and the fact that it's based around these large language models was designed to address some of these natural language processing limitations. The idea being that these large language models, starting with things like GPT-3 and moving onward into our ever larger and more powerful language models, are very good at least simulating an understanding of human language. If we give them instructions to do any of those tasks that I mentioned, like, okay, recognizing protein names or finding relationships between symptoms and diseases, they're from the beginning relatively good at those tasks, partially because they have kind of this inbuilt understanding of what we mean when we say disease, or when we say symptom. Sometimes it helps to provide some additional context and say, oh, well, we specifically mean this type of thing when we say disease. We can provide some examples. But previous approaches in natural language processing didn't necessarily have that benefit. Even with the larger language models like BERT, well, there was some of an inbuilt understanding of disease, but we kind of had to lead the model to that concept and really kind of coach it in what kind of output we wanted to generate. These newer models are just seemingly inherently good at a variety of different instruction, understanding, and language generation tasks that will combine to provide decent results for these kinds of approaches. The limiting factor, unfortunately, is that they're not quite so good at linking the extracted concepts or relationships to entries in databases. It's just not their strong point, partially due to the way that they're designed, partially due to the fact that, well, yeah, I mean, these databases are updating all the time. So even though some namespaces, like, for example, gene ontology, are in fact included in the training data for most of these large language models, what they don't do so well is that connection between the label and the identifier. They can get pretty close sometimes, but not in any reliable kind of way. In fact, in many cases, they have a tendency to just outright hallucinate. In some cases, new identifiers entirely. If I give a large language model a list of Go identifiers or the labels for gene ontology terms, it's likely that at least one, if not many of the items in that list will just be entirely generated, or at the very least variations on existing terms that just aren't quite right. Because, well, these models are designed to generate text. If I ask it to generate a new term, it will happily do so, but they don't always work quite as well for doing a lookup. Luckily, we have other tools for doing that. So that's what OntoGPT takes advantage of, is the fact that, well, large language models are good at some things, but other software like the Ontology Access Kit are much better at looking up things in ontologies and structured resources. With all that said, I think it's time to jump into the hands-on part of the workshop. Anybody have any initial questions before we jump into this? Okay, and yes, thank you, Sarah, for dropping that link back in the chat to the tutorial. I guess one initial question that I have for everyone here is how many people how many folks have used OntoGPT before? Maybe by show of any kind of reaction on Zoom. How many people have you? Okay, I see one. Okay, I see some reactions. How many folks have? How many folks currently have an OpenAI API key? If you do not, that is perfectly fine. But it may mean that I will. Okay, few. Okay. We can. I think that means that today we'll try to use this with Ollama. This does mean installing a local model. This can take a moment, mostly just to download the model itself, and it may not run on all machines, but we'll see what happens. OntoGPT does seem to work best with APIs like the OpenAI API, but yeah, certainly not mandatory as we enter an age where hopefully we'll be able to use more open models that don't require payment at the very least. So I'd say step one, if you're following along, is to install OntoGPT. This is all Python, so as long as you've got Python 3.9 or more recent on your system, then this should be okay. It installs through pip quite well if that is something you're familiar with using on the command line. If you have trouble, RAM is one of the limiting factors here. I see your comment, Patrick. If you have any trouble installing packages through pip, there are two things that can sometimes help here. One is to get Python to create a virtual environment. And that will usually look something like, and I'll drop this into the chat as well. Actually, I think I have a demo on the command line here. Usually that'll look something like this, where you have Python -m venv, or sometimes even virtual env, and then the name of the virtual environment that you want to create. You may have noticed that on my system, I have to tell it without pip, just to tell it not to install pip and then go back and install later. It's kind of tedious, but that's kind of the basic idea, is to install is to create a virtual environment. Then you can use the source command, which really just tells your command line, okay, well, this is the virtual environment that I want to enter. So it would just be the name that you created. That'll be the directory name /bin/activate. And then once you do that, it will take you into that virtual environment where you should be able to install the package through pip. I think you also have the option to use pipx which is essentially a version of pip that comes with some additional tooling to create a virtual environment for you. But that's one of the limiting factors that may arise, is if your system says, hold on, I don't want to just install any old package. You need to do that in a virtual environment. And at this point, if anybody has any trouble along the way, feel free just to speak up, and I'll jump in and see what we can do about it. But otherwise, I will assume that everybody is just rolling along at their own pace, or happy just to watch. So that may take a moment to install. Similarly, yeah, if you're trying to follow along and I'm going too fast here, just ask me to slow down. If you've gotten that ready to go, then there's actually two different ways that you can set an API key if you have it already. One is with the command here, run oak set API key -e, and then in this case OpenAI. Follow that just with your OpenAI API key without any kind of quotes. You can also kind of set it at more of your environment level with the export command. In this case, it'll literally just need to be OpenAI _API _key, all caps, followed by equals, no spaces, and then again your OpenAI API key without without any kind of quotes around it. So that should be ready to go for you. In OntoGPT, you can actually set API keys for other APIs. That way, there's some pages in the documentation that describe the exact IDs that you can use for that, but generally it's going to be the name of the service. If you and in some cases, you can also pass it directly through the command line if you have some kind of application that requires you to do that. If you don't have access to an OpenAI API key, like I said, we can use this Ollama package. So in fact, I'm going to try to demonstrate how to do that. The Ollama, in brief, is essentially a framework for running and retrieving local large language models. This doesn't actually require quite as much resources as you might expect. It can be a bit slow sometimes, but you don't need an incredibly powerful GPU or CPU or hardware. It does help, but at least for models that are capable of giving perfectly reasonable results, you can in fact download them and run them. The page here will mention how much disk space you need. That's one of the limiting factors. The 70B model is, pretty stout at 40 gigs. But with OntoGPT, you can actually get some fairly decent results, even just with the 8B or the 8 billion parameter model. And that's at a comparatively svelte 4.7 gigs of total disk space. You can see they also provide access to a variety of other models. But they do mention that even with those smaller models, they do expect at least about 8 gigs of RAM. That's kind of your bare minimum. And even at that, it may generate a little bit slowly. But that being said, yeah, pretty impressive that you can in fact run these on even a pretty average laptop these days. So go back here and let's see what we can do with this. To actually install Llama, you're probably going to want to visit their install instructions. On Linux, it essentially just has an install script. On Macs, it's not much more complicated than that. Wondering, that's because that is just a direct link to the installer binary. Interesting. I thought at one point they had a separate page for that. But yeah, essentially for Mac and Windows, they actually have installers that will do it for you, as well as a Docker image, conveniently enough. But the basic idea is that, yeah, this is software that will let you run essentially a local server that will provide access to that local model, at which point OntoGPT can then access that model. So just as a demo, let's see if I'm currently serving that. Oh, no, maybe it's already running. I do have that installed here. Let's see. This will tell me that okay, so I do actually have two models that I downloaded a couple months ago, including this Mistral Nemo model. I don't remember if that actually provided any better results for anything here, but that is one that we have. So then in any of our subsequent results, we can use or in OntoGPT, we can use this model command to say, okay, well, this is specifically the model that we want to use. So in this case, I'd say -- model OLlama / llama 3.1. I think in practice, I don't actually need to provide the this latest. So yeah, like I mentioned, if you run this OLlama pull command, that will download the model, and then you can, yeah, as long as this OLlama server is running on your system, then OntoGPT will be able to access it. Any questions before we start jumping into the real life-ish example here? Okay. So let's say we want to extract concepts from text. I'm going to imagine that we have a simply massive collection of documents. We don't want to go through them individually, but our goal here is that we want to be able to extract breeds of animals by name, and we want to ground them to the VBO, the vertebrate breed ontology. And in practice, these could be a variety of different types of animals. I just know, okay, well, they could be mentioned in the broad scheme of things like, oh, here's a pigeon, or they could mention it as a specific breed of pigeon. Like in this example here, we have the fantail, the Jacobin, the homing pigeon. So let's say we have a toy document here called pigeons.text, and this is its exact contents is 3 lines, each describing a breed of pigeon. So I'm going to go ahead and navigate to my OntoGPT directory here. I'm going to verify that I do in fact have that file already. Yep, I have pigeons.text. And yep, that's actually what it contains, is those 3 lines, because I made this document already. So our next step is to have a extraction schema that's going to be able to extract exactly what I want from these documents. I'll walk through what this contains, but if you've had any kind of contact with LinkML schemas before, well, guess what? That's exactly what this is. It's a LinkML schema rendered in the YAML script. So each LinkML schema, whether it's something that we're going to use in OntoGPT or not, we'll start with a header like this, providing a unique identifier. In practice, we'll often have this be a W3 ID, so it can kind of resolve back to a persistent URL. But we'll use these IDs just as a shorthand to refer to this specific schema. We'll give it a name and a human readable title, along with a description. Give it a license, just because that's good practice. Provide some prefixes for the namespaces that we may use. That's sometimes of less critical importance here, but definitely good to know exactly what we mean when we say something like RDF, even though that's generally going to be the same. We provide some basic prefixes, including for our namespace. We're going to call this all VBO names. We'll provide a default range. For extraction schemas in OntoGPT, this is almost always going to be string because, well, that's the form of information that our large language model is going to generate for us. We provide a couple imports and LinkML schemas. LinkML has some basic data types that we're going to use, and OntoGPT itself also has a set of core data types that we're going to import here through core. That means that when we define our classes, these are going to be kind of or at least this first one is going to be the root class. It's going to be the overall thing that everything's going to result back to when we're asking our LLM to provide results for us. So in this case, that's going to be a set of names. We just call it name set here. Now, the name of this class is something that actually is going to be passed to the LLM. It is going to know that we're trying to populate a thing called name set, so that that does matter a bit. These classes are things that are actually going to go into building prompts for us that are going to be passed to the model. We're going to say there's a named entity here, even though really this is a tree root, so it doesn't strictly need to be a named entity here. It just means that we're going to be able to take advantage of some of the things that we're going to import from the core schema here, because that's where this named entity is defined. But here we're going to give this 2 attributes. Each of these attributes is actually going to have a range that refers to another class, where we'll provide information about the individual objects. But the critical detail here is that each of these classes is going to be multi-valued. It's actually going to be a list of things, because we know that in any one of our documents, we could have one or more of the names that we're trying to extract. So here are our 2 slots on this name set class. First is going to be animal names. We're going to use that to extract all kind of the high-level animal names. We're going to provide that instruction in the description here and say, okay, this is going to be a semicolon separated list. We'll use a semicolon separated list so that OntoGPT knows how to parse it. And we're going to tell it explicitly, okay, this is going to be a list of names of animals using input text. We're going to go into detail, say, okay, these more general names. We're going to provide some examples like, okay, well, if any breed of cat is mentioned, this list should include cat breed. We're going to be specific with that format here because that's how the vertebrate breed ontology phrases these things. That's going to make it easier to ground things down the line. Or, for example, if there's any pig, we're going to say pig breed. And then we give that a range of animal name, which we define below. For the more specific names, well, we just call that names here, even though it's a little bit redundant with the animal names. But importantly, that has this range of breed name, which we've also defined below. In this case, again, we're going to say, okay, well, it's going to be a semicolon separated list of names of animal breeds. We define it as multi-valued. That's not necessarily something that the LLM will know about, but that's how OntoGPT knows, okay, well, this is going to come out as a list, so I'm going to parse it as a list. In this case, we've said, okay, well, this is going to be specific as possible about the breed of the animal. Provided some examples of specific breeds of, in this case, a duck, a pony, and a type of pig, I believe. So then below, I have my classes that define the specific things that are in that list. These are named entities. In this case, they explicitly are because OntoGPT is going to try to ground these specific things to terms in VBO. I've defined the annotators with this shorthand. This is what actually the ontology access kit uses to access annotators. Or in this case, an annotator is a thing where we will attempt to search for a corresponding name for the extracted text. So for example, here, if I extract cat breed, I'm going to look up that label in VBO in this case. SQLite just means that we're going to use a pre-built version of the SQLite database version of this ontology, which just makes it faster to access. OBO means that we're going to use the OBO Foundry version. VBO is the name of the ontology itself. We can use other things as annotators, and in fact use multiple annotators, but then actually ground it to a specific namespace here. I've actually omitted it here just for sake of brevity, but you can specify the exact prefixes that you want to have on your identifiers as well. That's useful for something like VBO because, well, VBO also includes NCBI taxon IDs. And if you didn't want those, you can specifically say in this schema, okay, well, I just want to restrict this to VBO prefixes. But in this case, well, I'm just going to say, okay, well, if it annotates in VBO, that's great. And then I provide a brief prompt description here that's saying, okay, well, this is going to be the name of a general category here. And I do the same for breed name. So relatively straightforward. And let's see how that actually does in practice. And I can run that. Come in like this. I'm just going to verify that I have that schema there. I've put this in the same. There's my VBO names. Okay, so that is in fact there. Let's take a look at that. And in fact, that is exactly what our example is here. I can run that. Now I'm in my, actually, in this case, sorry, this is something I didn't talk about. In the repo version of OntoGPT, we handle dependencies using the poetry package. If you install this with pip, that's not entirely necessary, but I'm using the version from the GitHub repository here. So I'm just going to preface things with poetry run to indicate, yeah, I want to use the existing poetry virtual environment. It just means that my dependencies are already ready to go on this. So I do poetry run in this case, but the critical part is OntoGPT extract -I is going to be my input. In this case, that's pigeons.text. -T is going to be VBO names. One thing that I did not do is I did not tell this what my API key is here. So let's give this an opportunity to attempt to use our open language model here. So I'm just going to paste that onto the end here. And I believe that was actually Llama 3.1. So let's see if that will do anything for us, or if that will yell at me. Like I mentioned, this can sometimes be a little bit slower, especially when it kind of needs to warm that up. The other option that I have here is to run this in more verbose mode. Oh, there we go. Okay, so actually I did get some results. So let's see if I got anything useful here. Nope, in this case, it looks like it ran, but for whatever reason, I did not actually get any results. So this is what happens when you don't get any results at all through here. Is it just said extracted object and an ID. So for whatever reason, it looks like this prompt was generated. Well, this is just one of the several prompts that were generated, but it looks like the language model in this case just did not understand what we were trying to do at all, which can happen sometimes with the open models. So what I'm going to do instead here is I'm going to put this in my extra the prompt. Yes. So I'm going to actually just drop the prompt. In this case, this is the prompt that you'd run without specifying the model at all. Oh, you want to show the prompt itself. So yeah, actually, let's take a look at that. So one of the things about, actually, let's make that a little bit more visible. One of the things about OntoGPT is that it runs prompts recursively. Rather than trying to squish everything into one big prompt, it'll iterate through the schema that we have. In practice, that means if we're starting with a schema like this, it's going to initially say, okay, well, I'm going through this item and I have an item with these two classes. Please follow these instructions and extract those things. If it gets any hits, like if it gets any of these animal names in a list, it's going to say, okay, well, now because I know that the range of each of these things in the list should be animal name. Now I'm going to go ahead and form a new prompt for each of these things. I'm going to do another round of grounding to attempt to extract things further. This isn't always completely necessary, but as we get into more nested and kind of more complicated representations of data, this becomes absolutely necessary because one round of extraction isn't always enough to find what we're looking for. And that is actually one area where OntoGPT's behavior kind of differs from some of the other tooling that's out there.
So I guess I have a question about that recursive prompting. So that sorry about screaming child in the background.
Hi.
So the source being, or the annotator being SQLite, OBO, VBO, is the whole of every named entity in that database put into the prompt, and you say, all right, now pick out from these specific entities?
Nope. And in fact, the LLM has no exposure to the ontology at all.
I see.
It has no idea what ontology you're using unless you explicitly say, like, try to ground this to a whatever term, which I found tends to not work very well. Yeah, it has no idea what you're trying to do, and it will only get as far as we want it to, which is extracting kind of the pre-grounded results.
Gotcha.
So if I go back even to the prompt here, so the prompt that is showing here is the kind of the top level prompt. And in this case, what my expectation is, and I could probably dig into this a little bit more and see if it's having trouble with Olama or even that model itself. In this case, it didn't get any farther than that. So this is essentially the first prompt that it ran, is more of kind of a literal representation of the schema itself. But what I'm going to do here is I'm going to give it my my OntoGPT API key in secret. This is being recorded, and I don't want to share my API key with. Okay, so now I'm going to run that again. By default, this is going to use GPT-4 Turbo, I believe. So that'll be a bit faster. And like I said, I provided it my my API key through export. And now, well, okay, we do actually have results now. So I'm going to start from the top here because it's going to look a little bit different. Our input text is exactly the same as it was before. But now we actually have this raw completion output where it provided, kind of initial extractions from our prompting. So it says, okay, well, animal names. Okay, well, I found pigeon breed, and I even extracted some additional breed names based on those descriptions. So we'll see, okay, well, in practice, our prompt, is going to look the same as the other one, except in this case, it actually was able to get something out of it. And importantly, we also provide that input text. OntoGPT has some options where you don't always have to send it the complete input text. You can certainly chunk it up a little bit. This used to be more necessary for models because they had a smaller frame of text that you could pass them at one point. Anymore, they can accept quite a bit more text and provide a lot more output. In some cases, it's quite fantastically large amounts of input or output for a single query, to the point that it's you really can pass the entire text of a given document, and with mixed results depending on what you're trying to do. But the critical detail here is, okay, well, we actually have an extracted object now. We have our animal names, and it did us the courtesy of grounding that to a corresponding VBO term. Same for our names, or at least in two of our cases, it got this one, which it's listed on our named entity. So that's where it's actually going to show us the corresponding label. I'll caution that the label shown here is actually the label that came out of the LLM. We told it we wanted to render this as pigeon breed because that's what's going to ground to VBO better. In fact, it does. Whereas the text here explicitly says pigeon. So that's what it picked up on. That means that if we hadn't provided those instructions, it may very well find something that's just very similar, but not. This is not the exact label coming out of VBO. So this is mostly just so you can get a better idea where it's getting the text from. But it does find some of our specific breeds as well, like fantail. It does not actually find this Jacobin simply because the text in VBO is just slightly different. I think I made a note about that down here somewhere. Yes, so that's simply because the label in VBO is actually Danish Jacobin pigeon, which isn't quite close enough for OntoGPT to say, this is definitely the same thing. And in fact, OntoGPT is generally pretty conservative about doing those matches. There's related software that we call CurateGPT that is able to do some broader matches because it does vector search. But for now, OntoGPT is, relatively restrictive in terms of the strings that it can matches. It does a little bit of pre-processing, but it's not doing vector search. So it's not going to find instances like this. So we don't necessarily have to stop at those entities. Any questions for the moment? Okay. If not, I'm going to go ahead and roll onward to extracting relationships. So let's say we're not happy enough just saying, okay, well, I can extract the fact that there are pigeons in this text or mentioned. I can extract their specific breed names. Let's take this one step further and say, okay, I want to try to extract the exact characteristics of each breed. We know that that's mentioned in the text. It says, okay, well, fantail is a popular breed of pigeon known for its distinctive fan-shaped tail feathers. Okay, well, can I structure that kind of relationship a bit more? And it turns out, well, yes, we can. We just need to make some updates to our schema to provide those instructions. So the header here is still going to be the same, and in fact, most of this is quite similar to that last schema that we saw. We're even still saying, okay, we're going to extract a name set, but we're going to add a new class to it called characteristics. This is similarly going to be multi-valued. We're going to provide a couple details here. These inline is this. That's just going to change how the output renders in our final output here. But I'm going to provide some descriptions here to the LLM to extract exactly what I want. There's going to be a list again, and I'm going to say, okay, well, I'm going to provide the same kind of level of detail that I did in the names, the animal names and the names again, because, well, this is extraction. In this case, essentially has to do the name extraction and then the relationship extraction on top of that. So it's kind of doing it all at once. So we're going to have it extract a name of an animal breed, or rather, it doesn't need to do this first one because it's going to extract the breed and then the characteristics. I'm going to define characteristics pretty broadly here and say, okay, well, characteristics might be color, dimensions, physical properties. I don't need to get it exactly right at this point because that's what those subsequent classes are for. They can do a little bit more of the refining and say, okay, well, this is actually what this should be. But in general, I'm going to give this instructions to extract these things kind of like triples, where I'm going to say, okay, well, the Gimsheimer Enten is blue. And I think in practice it is kind of bluish gray. My general idea here is that, well, I want to try to ground some of these characteristics as well. I don't need to worry about that as much here in anything other than the general format and the types of things that I'm going to extract. So I provide some examples as well. That's always helpful. And then down here below, I've defined the breed characteristic as a triple. Luckily, this triple is already a data structure that's defined in the core schema of OntoGPT. So I just import that and kind of build on top of it. So that's why I use the slot usage command here. I'm just saying, okay, well, this data structure already has a subject, an object, and a predicate. I'm just going to modify that a little bit. I'm going to say in this case, well, our subject is going to need to be the name of breed. That's what I'm going to try to ground it to. The object is going to have to be a characteristic, which is a new class that I've added above here. Predicate, I'm not going to try to ground that here per se, but I am going to tell it, okay, well, it's probably going to be is or has. And then I've included the subject qualifier and object qualifiers just to kind of capture any additional details here. And I can try to ground descriptor as well. This is something that the Pato ontology is great at, is providing terms for things like characteristics, especially physical characteristics of things like, in this case, animal breeds. And for characteristic, I've realized, okay, well, sometimes it's actually going to be like a tail. In other cases, it's going to be more of, a feature itself. In practice, this is kind of area where I could really go down a metaphorical rabbit hole and, try to define, specific properties of tails, like say, okay, well, I have an ontology here that defines the exact, the specific types of shape that tail feathers may be in. And I can get as specific as that. Or in this case, I can just try to start from something very general and see what kind of things I get. So yeah, very, very use case dependent. But sometimes it pays just to see what kind of general things we can extract first. This is exactly the kind of flexibility that we get from this approach that, unfortunately, with previous NLP approaches, that would require perhaps an entirely new training set or generating an entirely new set of results that we need to evaluate separately. So if we use that, and I'm going to go ahead and run this, I'm going to use exactly the same input as before, and I'm going to use the same. I'm going to use this schema from above. Let's go ahead and drop that in here and see what kind of results we get. Now, while it generates, I'm also going to mention that the framework that I wonder why I tried to use that. Interesting. Haven't seen that error in a while. Interesting. Anyway, OntoGPT has features to do caching, meaning if you run more or less exactly the same kind of extraction with the same schema, it will cache your results. It does this for individual parts of that recursive process. So let's say you have a schema where you've modified other things but kept some intact. Like in this case, well, we previously extracted those breed names. So OntoGPT is perfectly capable of using those cached results first, because, well, those were essentially a query in their own right. I thought I'd have a cached results for this, but maybe it's decided that it's, oh, I know what the problem is. I forgot to use my poetry run. Yeah, I was kind of confused as to why I was seeing that error, because that should not be appearing in a recent version of OntoGPT. So there we go. Okay, so this should actually be quite a bit faster, as it'll be able to use the cache that we generated before, and more importantly, a more recent version of OntoGPT. There we go. Okay, so let's see, how did it do? Well, our input text is still the same as before. Our raw completion output, it has some of this raw completion, so we can see, okay, well, it has our characteristics now. And we have things like fantail has fan-shaped tail feathers. Great. Okay. Jacobin has distinctive crest. Jacobin has hood of feathers around its head and neck. Homing pigeon is fast. Okay. Homing pigeon has navigational abilities. Okay, so reasonable extractions, but are they the kind of things that actually A, go into the level of detail that we wanted them to, and B, are able to be grounded? And they may be able to. They are in a slightly more structured form. And well, yeah, in some cases it looks like they did ground. We say, okay, well that's a breed right there, and specifically look that up here. Okay, well that's the fantail. That's great. And we'll see whatever this Uberon term is. Uberon 18537. That's tail feathers. Okay, so it did do a little bit of truncation there. Saying that this breed has tail feathers may not go into quite enough detail when really what we want to be able to do is say, okay, well, it has those fan-shaped tail feathers. So this may be a point where we'd want to go back into our schema and say, okay, well, we want to be able to ground that fan-shaped a little bit differently. And I was hoping the way that this would work is, okay, well, we take that fan shape and we ground that on its own. But these are times where, well, maybe in some of these cases we don't want to ground it because we do want to retain that original string of fan shaped tail feathers. Maybe that has more meaning to us on its own than just tail feathers alone. That being said, we could restructure this a bit and say, okay, well, maybe it's not meaningful for us to say fantail has tail feathers, but it is meaningful for us to say fantail has tail feathers and the tail feathers are fan shaped, and kind of structure that maybe as more of a kind of this property graph with an kind of a higher level association kind of model defining the overall characteristic. And that's where kind of another strength of OntoGPT comes in, and maybe even more broadly LinkML, which is that these extraction schemas don't necessarily have to follow a specific data model. LinkML's built around more this idea that you're using a something kind of sort of like a property graph. It doesn't have to be. If you want to define things that are going to go into more traditional RDF triples, it's perfectly happy to do that. If you want to define slots that are going to be used as properties on nodes or edges, that's entirely doable as well. The extraction schemas and LinkML itself are generally agnostic as to kind of the underlying structure. As long as you can represent it in schema, then yeah, you're ready to go. So yeah, at this point, at least we have a set of triples. Yeah, they may not go into quite the same level of detail, and in some cases they aren't entirely grounded. We weren't able to ground homing pigeon before as it is. So now we have things like homing pigeon has abilities. Again, maybe not quite the level of detail we're looking for, but well, it is a triple, and that's exactly the kind of thing that we want to be able to identify or base further extractions off of. And I didn't mention this before, but something that recently got added to OntoGPT was this ability to find the original spans for these things, which can be useful if you're saying something like, okay, well, I have a grounded term for crest that links to an Uberon term here. Where was it actually in my input text? So I can go back and label it myself, and that's provided now as well. That only works with things that are at least very close to being the original text, case insensitive kind of way, and maybe we can generalize that a bit in the future. But that takes it back into the realm of more traditional name identity recognition kind of approaches. All right, and that's largely the tutorial today. I've in the tutorial on the O book, I've provided an additional example of how you can use OntoGPT with the web extract command. This command essentially lets you extract information from a given website. The LLMs have no qualms with reading directly from HTML. So as long as it's rendered on a page, then well, you can use it. In this case, I have this page describing a specific breed of pig. So this is what it looks like. Talking about this Fangjing breed of swine. lot of great information here. So can we use this with our existing schema, despite the fact that we designed it for, use with pigeons? We didn't, explicitly say like, okay, well, this has to be pigeons. We just said, okay, well, extract these names, and let's see if we can get the same kind of results that we did here. The spoiler is yes, we probably can, but as long as I use here. So that's just OntoGPT web extract, same template as before, but instead of that input, I'm going to give it the URL to that page. So that's probably not going to take too long because that's going to use the OpenAI API again. It's going to yell at me a little bit just due to how it's going to parse that HTML. But there we go. And we can see that there was quite a bit more text in this input. And in fact, all that's going to be up here. So I'm not even going to bother looking at that because, well, it's the entirety of that web page. But we can see that it extracted animal names. That's just going to be, pig breed, I believe. In this case, it did also get the corresponding NCBI taxon. I think in this case, because it mentioned swine, and that's a term that ends up showing up in NCBI taxon. So it has the corresponding Sus scrofa ID, and it also extracted several different names of the breeds as well as characteristics of those breeds. So yeah, it's already grabbing things like, okay, well, they have back fat thickness. Again, as above, we might want to go into a little bit more detail and say, okay, well, what kind of back fat thickness are we looking at here? We know it's okay. Well, they have litters. That's great, but what's notable about their litters? But yeah, we can see at the very least, well, we extracted swine, and it mentioned it a great number of times in one document, which makes sense. But yeah, in practice, we can do this with most web pages that have text on them, and we can turn them into structured data. We could even go further and say, okay, well, it's actually really important to us to know what their litter size generally is, or what time when they reach puberty, what their life cycle is like, and we could tell our schema, okay, well, these are the kind of things that we want to be able to extract. And yeah, and so that works with web pages. There's separate commands for working with PubMed papers, so you can actually search directly through OntoGPT interface or over PubMed or Wikipedia and get the corresponding pages. So with that, yeah, we're running down to the end of our hour here. So if anyone has any quick questions, this is a great time for it, or feel free to contact me on Slack. I'm on the OBO Slack, and yeah, be happy to answer any questions about OntoGPT and otherwise.